Many developing nations are experiencing industrial expansion. Although this advancement benefits the international economy, it creates a greater demand for global energy sources. Petroleum is a commonly used resource whose cost-effectiveness makes it a high-demand fuel source. Unfortunately, the combustion of petroleum releases greenhouse gases, such as CO2, into the atmosphere. These gases are hazardous pollutants that threaten human and environmental health. An alternative to petroleum is biofuel, a sustainable energy source that can meet increasing energy demands without causing further ecological harm. So, more specifically, what is biofuel and where does it come from? Biofuels are fuels sourced from biomass. Biomass can be derived from crops, but using food sources as fuel can destabilize the food security of developing nations. Additionally, crops require vast portions of farmland to grow. Microalgae can be used instead of crop-derived biofuels. Microalgae's rapid growth rates, adaptive abilities, and high lipid accumulation capacity make them promising biofuel producers. Lipid accumulation is the ability of microalgae to produce neutral lipids or oils, which can be extracted and used to create biodiesel. Now that we know what biofuel is, let's dive into how microalgae is used to produce biofuel. Before oils and microalgae can be converted into biodiesel, they must be extracted from microalgal cells. Unfortunately, microalgae's thick cell walls make lipid extraction for biofuel production very difficult. Before extraction processes can occur, it is necessary to pre-treat microalgae to disrupt the cell walls and allow for easier lipid extraction. Pre-treatment processes can be physical or chemical. Physical pre-treatment processes often expend a lot of energy, which is counterproductive to the goal of microalgae being used as a sustainable fuel source. On the other hand, chemical pretreatment methods involve the use of chemicals that can cause immense ecological harm. The objective of this video is to educate the viewers on different methods of optimizing oil growth in microalgae to minimize the need for pretreatment before lipid extraction. Many species of microalgae are characterized by their adaptability to various environments. Environmental parameters such as pH, temperature, and nutrient availability can affect the type and concentration of microalgal lipids. Research performed on microalgae growth parameters over the past few decades has indicated that the oil content of microalgae can be maximized when ideal parameters are set. For example, Andreeva et al. Found that adding 5 grams per liter of sucrose to the microalgae species Chlorella vulgaris led to a promising increase in lipid accumulation during its early growth phases. Similarly, Yu et al. Identified the most suitable pH for optimized lipid accumulation in microalgae as falling within the range of 7 to 9. In conclusion, microalgae is emerging as an ideal sustainable fuel source, yet there are still many hurdles to overcome before microalgae-sourced biofuel can become more widespread. Many of these obstacles center around the expenses required for pretreatment and extraction processes. To optimize the amount of biofuel that can be derived from microalgae, it is necessary to control for the ideal parameters that will result in maximized lipid growth during microalgae cultivation. Controlling for the best possible parameters in microalgae growth will allow microalgae to rise as a prominent, efficient fuel source that can meet increasing global energy demands. If you want to learn more about microalgae's potential as a biofuel producer, read more on frontiersin.org.